What's going on, PlayDate community? We're back with another episode of Real Money! And this is update number 4. What did we do this week? We sped things up. We need to go real fast. We're gonna learn to do some Lua. So, I've got last week's build running on Buggy. We're gonna sample it. I'm gonna show you guys. So here we've got the simulator open. Of course the game is running on the device like full speed. Zoom into that. And you can see that the title screen goes down all the way to 25 FPS, which is slow. So what we do is we're gonna hit the sampler, which is over there in this little timer in the PlayDate simulator. Open down the drop down, we're gonna click device, Lua, and we're gonna hit sample. So now what the sampler is doing is that it's showing us everything that's running. So every function that's running in Lua is being timed, and that total time is allocated as a percentage of CPU. So as you can see, the draw method from the painter is taking up 25% because the painter is just drawing everywhere. We've got the title draw method, which is taking up a lot. Garbage collector, which is at 7%, which is absurdly high because I still didn't fix the frames problem. And then number 4, we've got this function called getAnimatorValue. When I saw that, I was like, okay, what? It should be taking 1 second. Of course, I decided to focus on that one because the other ones were more difficult. So let me show you what it looks like. So let's jump in. We've got the widget animator dependency file, which is over here. And the first function is the getAnimatorValue. So as you can see, it's doing a lot of stuff. Basically what it's doing is we have an animator, which is the PlayDate SDK's animator. It just gets the current value, except that you can call, even if the animator is stopped, or even if the animator doesn't exist, and actually do sums of multiple animators, it will return a value no matter what. So for example, let's say you have 2 animators going in different directions. You want to just sum up their values, and you're not even sure if they exist. Compiles all the animators together. If they exist, great. If they don't exist, return 0. I thought I was being clever when I made this, but actually I wrote it so badly that I wasn't being clever at all. So what's wrong with this? So if we look at this, first we have these 3 dot operators, which is basically give me as many arguments as you want. Then we iterate through the animators using animator. And basically what do we do here? Get meta table. Sounds crazy. That's a Lua function where Lua, basically all the tables, they can have a meta table that points to that table. And that's, for example, how object orientation is handled. The meta table will say, oh, these functions can be used. The table itself doesn't hold any data, but the meta table says you have all these functions available to you. It's a pretty original Lua concept. We'll probably see it again. And basically what I was using it for is that tables have meta tables, numbers don't. So basically I was saying, okay, if there's no meta table, then this is a number. If there is a meta table and the name of this meta table, which of course refers to the class, is a PlayDate geometry point. So these 2 values are saved here, and these are the default values. So any further value gets added to it. Just this operation here is enough to slow the game down quite a lot, because basically it's a table lookup, but not an inside table lookup, but an outside table lookup, which is not good. So I went ahead and prepared this thing for you guys. Lua performance tips, how to free yourself from Lua. What I'm going to show you is that this example here, this is what I learned to do last week. Here you can see an example function that runs with math.sign. It can be math.max if you want to, or something else. And what we're doing is that we're removing the table lookup within the for loop. So actually the table lookup happens once, and then we basically use the function that we already extracted above. And so what happens is that when you run this, it does run 30% faster without the table lookup. So these table lookups are very expensive, plus the string comparison. I mean, I don't think that's crazy expensive. But anyways, it's not the fastest way of doing it. So what did we do? Oh my God, it's gonna die. We are back, and here I'm showing you this current version of getAnimatorValue. So what I've done is that I've gone ahead and assigned all these local constants to avoid all these extra lookups. Now, this one, you might be saying, what's up with this one? Like, it looks exactly the same. You could either do typo, no pun intended. You could either do type or type. What's the difference? The difference is that when you do type without the underscore, you're actually doing a lookup in the global table. In fact, if we just run it here and wait till it hits, we're going to see that type actually belongs to a table which is over here called env. and you've got all the different functions that are global inside env. That's your fun fact for the day.
Have fun.
So what we do is that we assign it locally, and that avoids us the lookup. So it's much faster.
Is number.
Type equals number. Okay, that's how we simplified it.
Is number.
If it's not a number, then we call it a geopoint.
Is number.
That's it. And so this actually runs much, much faster if we run it, which I'll be running it on simulator, so maybe it's not a fair comparison. But if we run it here, you'll see that this animator function, okay, we reduced its overhead by 2%.
Still expensive.
Oh, it's now at 5%. So we reduced it by 1%, guys.
Good job. Good job, everybody.
The good news is that I actually wrote a script that runs this all over your project, where basically any references to PlayDate graphics or whatever single library that you're using, if you're stupid like me and you use PlayDate.graphics because you thought it was cooler, you're actually much better off using the library locally. It's much faster. The script is over here, and drop it in the comments if you want to use it. You get to put in whatever libraries you want and however you want them to look like. And if it's playdate dot whatever you wrote, then it'll replace it with whatever else you wrote. Graphics, GFX. Other update.
Guess what? We don't have any new features.
But we have a
Widgets framework update. Do we? No, we don't.
We have an
Engine update.
I've introduced the idea
Of the logical sprite.
which is the logical sprite doesn't have to have a sprite that's on the scene, but it actually manages the kind of meta sprite. And the point is that when it doesn't have a sprite on the scene, it's much lighter. It's a much more lightweight thing. So it kind of goes hand in hand with the sprite cycler. And I made something else which handles what I called config, which is actually just state, and that's going to come later. So I hope that was enough. As you can see inside each of these, I assign local tables, and they're just a speed up for your game. So don't forget to assign local. And next week, we're going to be cleaning up this piece of crap, which I've made, which is called rect. And PlayDate actually has a geometry rect inside it. I just thought I was cooler than them, which I now regret dearly. Panic.
Please send me money, thanks.
These rects are going to go out the window, and what we're going to do is that we're going to create a dependency that handles drawing. And within that dependency, we're going to handle everything from dirty rects to this thing called painters, which I made. And we're going to handle everything in a much more efficient manner.
Thank you very much.
I know there wasn't much this week, but I hope you enjoyed it anyways. Like and subscribe and download the game and give it a shot, because it runs. It probably has some bugs in it. So, go ahead and find those for me.
Thank you.
I will see you next week for update number 5. Goodbye, everyone.